We are a university to some extent in physical isolation, but we are deeply connected in our relationships with other universities and other research institutions. We're deeply connected through a whole series of rich partnerships with organisations here in Australia, but many further afield. We're the University of Tasmania. We also claim to be the University for Tasmania, so we're absolutely confident that we've structured ourselves to meet those goals and objectives. And we also want to continue to be one of the world's leading research-led institutions.
I'm Professor Michael Bredmore. I'm an ARC Future Fellow at the University of Tasmania, working in the Australian Centre for Research on Separation Science. Scantex is technology and chemistry that's been developed at the University of Tasmania over the last 12 years to rapidly detect homemade explosives. Throughout that process, we started to work with a company called Grey Innovation to help us deliver the extraction component of that explosive system. What Scantex can do is we can detect homemade explosives with a level of sensitivity 100 to 1,000 times lower than all other existing technology in the screening place today. And that means we'll have a better ability to be able to detect people with explosive residues on them. Grey Innovation choose to work with us because of what we can offer them. But I also think that they're a very progressive company and we're a very progressive university. Being a small university that's very open to new ways of engaging and interacting with a variety of organisations, that we have a different way of thinking about collaborating with industry. We're much more flexible, we have a much tighter agenda in terms of delivering technology and products that will impact on Tasmania and society, and we can be a little bit more agile, I think, than other universities can in dealing with opportunities that arise. In terms of satisfaction, I mean, as an academic, to think that what we are interested in doing might actually change the way that we do something, so it might make airport screening simpler or more safe, and that will ultimately impact on hundreds of thousands, perhaps millions of people around the world. And to think that that came from the University of Tasmania is just an awe-inspiring experience.
My name is Dr. Lucia McCallum. I'm a geodesist at the University of Tasmania, and I'm working in the ASET VLBI project. Our task is to provide the most accurate coordinate system of the Earth using radio telescopes. So we are listening to radio galaxies far, far away. These are the furthest objects we know, but they are also the most precise objects. By listening to them, we can precisely measure the distances between radio telescopes on the surface of the Earth. So that's how we measure the distance between Hobart and our telescope in Katherine in the Northern Territory with about 4mm precision at the moment. The project is run under AUSCOP. AUSCOP is a big geospatial research infrastructure initiative from the government. The University of Tasmania has a long history in expertise in radio astronomy, using it for astronomical purposes, and that's why Geoscience Australia selected UTAS as their partner to build the new telescopes, to develop the techniques, the back-ends, the receivers, and also to do these observations. Our contract is not for research, our contract is for the operations, but we have a great deal of freedom. It's a great partnership because the observations themselves are the research, and that's basically the decisions they made. Do we just want to do it, or do we actually want to take an active part, be world leading, and help the global community in developing this technique? And that's why we are having this partnership, and I think it's great.
My name's Peter Dargaville, and I'm a staff specialist here at the Royal Hobart Hospital in the Neonatal and Paediatric Intensive Care Unit. The device we developed is one to control the concentration of oxygen that we give to babies who are receiving respiratory support, as they often need. We measure the content of oxygen in a baby's bloodstream using a probe, and then have within our device a set of computational instructions or an algorithm which determines what change we should make to the concentration of oxygen that we're delivering to the baby. The development of our system, I guess, is a good example of multidisciplinary research. It involved me as a clinician and a clinician researcher, recognising the problem that we had, believing there could be a solution, and then involving and finding the right person in engineering at UTAS, Tim Gale, to be a part of the project. And so there's been an input of a lot of students at all levels and a lot of time given over to making our device work properly. So now, having come this far with the device, we're really looking forward to the next few years of a global rollout of the algorithm in respiratory support devices. And we have found a very strong commercial partner in a ventilation company based in the UK called SLE. But also continued work on making the algorithm better and making the device more responsive and able to adjust its output according to the needs of every individual.
My name's Harry Tams. I'm CEO of Youth Futures Incorporated. We do training in agribusiness and manufacturing, and we build little microhouses called castles together with the University of Tasmania. A beautiful part of this was that we would build them ourselves with our participants, giving them the work experience and the skills to get work in whatever setting. In the design process, together with School of Architecture and Design, we see each other very regularly, almost daily. And we're working through the design issues or technology issues and the software that is required for that digital fabrication. We're always working at solutions, and we end up with a very beautiful product because of it. To have that joining together of physical spaces, architecture students coming to Youth Futures, which is a couple of 100 meters away, and our participants coming here and working in the studio, it does break those barriers. It gets them to think about that further education. And there's many, many, many young people working at developing housing for young people, which is fabulous.
I'm Professor Roger Stanley. I'm the Director of the Centre for Food Innovation. This collaboration was set up to focus on developing high added value products for both defence application and for the benefit of Australian industry. A lead project we have at the moment is MATS. MATS stands for Microwave Assisted Thermal Sterilisation. The aim of this research is to create food that, although it has a longer shelf life, it actually tastes much closer to as fresh cooked. The microwave technology preserves the fresh eating quality, which helps people actually consume the amount of food that they need out in the field. The Defence Research Facility for Food here at Scottsdale has been purpose designed to develop long-life foods and to test the nutrition and health properties of those foods. They have the special facilities that can shelf life test the foods for the extended 2-year period required, and this, with the food safety and quality measuring capabilities of the university and CSIRO, brings together a team that can achieve research of national significance for Australia.
Aerator has been a really interesting project. It began 2 years ago when we responded to a call from SenseT, who were looking for projects that involved using technology and sensing technology for the benefit of Tasmania. Both asthma and hay fever can be really debilitating and affect day-to-day quality of life, unless it's really well controlled. We consulted widely with our partners and stakeholders and came up with the idea of having a system that would tell individual users about their environment, and particularly about things in their environment that might affect their health. We work with Bureau of Meteorology because they have a network of weather stations, and we work very closely with the EPA, and they both have systems where they can upload that information in very close to real time. The big challenge was pollen, because there's no automatic system for pollen. It's an area of active research around the world, but really to know about pollen you need to collect it manually and you need to check every day. So it's an iterative process. We have regular meetings with all our stakeholders and talk about how it's going, what we can do to improve it, but it's definitely filling a need. People want this information and they find it useful.
My name's Steve Thomas and I'm the Creative Director here at Raw Film in Hobart. We recently worked with Professor Hamish Maxwell-Stewart from UTAS to create an online game called The Voyage. So the voyage is a game where the player becomes the surgeon superintendent of a convict ship. The idea sprang out of a number of conversations that we'd had with Hamish. People believed that convict voyages were hellish journeys into degradation, where in actual fact, whilst there were some very bad voyages, most of them weren't like that. The voyages were actually run by a surgeon superintendent. So much of the game is about keeping convicts safe and to get them to the other side of the world in a healthy condition. The voyage is a classic example of a really creative collaboration. It's a rather unique symbiotic relationship in that we're a private company and Hamish is call him an entrepreneurial academic whose aim is to get his area of information out into the world. So it works as a sort of unique collaboration for both of us.
I'm Neil Bowes. I'm the principal of the Australian Maritime College at the University of Tasmania. The autonomous underwater vehicle is specially designed for our Antarctic science applications. This one can dive to 5,000 metres, which is a significant depth for a vehicle to go to. It's also somewhat unique because it can park on the seabed or park underneath the ice sheets. The key to the vehicle is the sensors that are on board. We already have integrated on this system a range of sensors, but we have a whole load of other sensors that will integrate with the vehicle. The vehicle was built with support from the Antarctic Gateway Partnership, so its primary use in the first few years of operation we see as doing Antarctic science. Looking forward, we see partnerships with the Defence Science Technology Group, and also we're in conversation with several of the service companies to the offshore and gas sector for operations there. For us here in the Australian Maritime College, this is an extremely exciting project. Extremely exciting for students coming in, for PhD students coming here, and we do see it as growing our underwater vehicles research.
By working with industry bodies, either representative bodies or individual companies, we're knitted into the economic fabric of Tasmania. And from that springs the opportunity for the future. So our current conversation is around research futures. In what way do we need to support our research to maintain and build the reputation of the university? It is about our future, but also about the contribution we make to the future of this country and to the future of the people who live here.